Hello guys, welcome back to my channel Gamma Digamma. I know it's been a long time, and I've decided to make an introductory video to a calculus sequence that I'll be doing in the future. So let's get right to it. So today we are going to do a limit question. The limit as x tends to 0 of the natural log of x factorial to the xth root. So looking at this, I want to use some log properties and I have to bring this power down. You can multiply powers. That's one of the log properties. It is x tends to 0 of the natural log of x factorial over x. Looking at this is a 0 factorial. When I substitute, it's 0 factorial, which is 1. Natural log of 1 is 0. And even in the denominator, I have a 0. So on substitution, this becomes the type 0 by 0. And since it's a 0 by 0 form, for all of you who have done calculus in the past, you know how to calculate limits. We'll have to use L'Hopital's rule. I'll remind you there's a circumflex on top, and I'll also remind you that we have to differentiate the top and the bottom. I'll just write the general form. So limit as x tends to a of ratio f of x by g of x, for example. If it's a indeterminate form, like say 0 by 0 or so like infinity by infinity, then it doesn't matter whether we differentiate the numerator divided by the derivative of the denominator. Both of them mean the same thing. So applying that same thing over here, we now have the limit as x tends to 0. Differentiating the natural log function is just derivative of x factorial over x factorial, and because the derivative of x is just 1. I'm assuming you know how to differentiate the natural log. Wait, I'll just write it down for you. So say the derivative of say ln of f of x function is equal to f dash of x over f of x. I just use the same thing over here. Okay, moving forward, differentiating the factorial function is funny because it's a discrete function. It's defined for positive integers. We need something more continuous, for differentiation. So there is something known as let me use another color. There is something known as the gamma function. So the gamma of x plus 1 is equal to x factorial, and the great thing is the gamma function is defined for all x's, even all numbers, like even the negative ones. And so because of its continuous nature, I'll write the question as limit as x tends to 0 of gamma prime of x plus 1 over the gamma of x plus 1. Now there's also something known as the digamma function. I know there's a lot of gammas there, but you know, mathematician. So the digamma of say x plus 1 is equal to the derivative of the natural log of the gamma of x plus 1, which is, you know, from the above formula, is just gamma prime of x plus 1 over gamma of x plus 1. And when I multiply this with digamma, the question can be rewritten as, so gamma prime is basically the gamma of x plus 1 times the digamma of x plus 1 over the gamma of x plus 1. Now the great thing here, I mean, to be honest, there was no need to introduce the digamma function, because anyways you guys must be ready to cancel this and this. But this is really interesting because it's the gamma of x plus 1 times the digamma of x plus 1. And that also happens to be my channel name. I know, serendipity. And I guess you guys know why I must have chosen this question. Why I introduced the digamma function, you know. It's a great way to introduce a calculus sequence that I'll be doing, as I said. Now finally I'm cancelling this out, and all we are left with is okay, let's substitute x also, x in over here. So 0 plus 1 is 1, so the question is all reduced to the digamma of 1. So we need to find the digamma of 1. Now the digamma function, it so happens, is defined by this formula plus the sum from 1 to infinity 1 over n minus 1 over n plus x. And for the digamma of 1, we just need to substitute x as 0. So when x equals 0, it's gonna be digamma of 1 is equal to just this constant, and when x is 0, this is going to be 1 over n. 1 over n minus 1 over n is 0. This whole thing disappears, and this constant is the famous Euler-Mascheroni constant. So, you know, just writing the question down properly again. So the limit as x goes to 0 of the natural log of x factorial to the 1 by x power is basically the negative Euler-Mascheroni constant. So yeah guys, that's it for this video. I hope you like, share and subscribe. Thank you. Have a great day.